We're waiting to go online on YouTube.
I have to put my phone on silent. There we go.
Okay, I think we are online, so let's start.
Okay.
Hello everyone, and welcome to another talk in our webinar series. I'd like to remember that this webinar is also being streamed live on YouTube. You can find the link on our website or access it on our YouTube channel /LIneA MCTI. Today we have Carolina Ödman-Govender from the University of Western Cape presenting, talking about the socio-economic benefits from astronomy. Carolina, thank you very much for accepting our invitation and being with us. The floor is yours.
Thank you. Thank you. Good morning in Brazil and good afternoon here in South Africa. I would like to thank you very much for the invitation to come and talk about the socio-economic benefits from astronomy. And today I'm going to tell the story of how South Africa has really used astronomy and scientific excellence as a tool for the development of the country, and some of the magic that has happened. So I come from the Inter-University Institute for Data Intensive Astronomy, which is a partnership between the University of Cape Town, the University of the Western Cape, and the University of Pretoria. I myself am based at the University of the Western Cape. Okay, so let's start. I first want to define what we mean by scientific excellence. And for that, I'd like to quote the Global Young Academy that says that scientific excellence is excellence in all aspects of the scientific endeavor. So not just excellence in scientific research, but also in connecting science to society, in teaching and mentoring scientists, in science management, and in science advice to policymakers, to name only a few. So this is a really good all-around picture of definition of scientific excellence. At the same time, in South Africa, the universities are based on three pillars. We call them the three pillars of universities, which are research, education, but also community engagement, because we feel very strongly that none of our activities in universities is isolated from the society in which we are and of which we are full members. And so looking at this perspective, let's also look at development, what we mean by development. Let me see if I can get the slide, there we go. And so the accepted definition, if you will, for development is the current working definition of the 17 Sustainable Development Goals that are defined by the United Nations. And they have come after the first 15 years of the new millennium, which where we had the Millennium Development Goals. So this is now the second tranche. And these are 17 goals that have been studied a lot and are considered key for development. There are exactly 169 targets to reach and 232 indicators of progress in each of these 17 goals. So we take on the one hand scientific excellence and on the other hand development. And so how can science and scientific excellence take part in development? So we have the scientific fields that are directly in development. So that's more direct, you know, we think of public health, we think of energy, water management, agricultural sciences, etc. And those are sciences that concern development directly. And they also have a voice in policy making to ensure that the scientific outputs lead to policy changes. And when that is followed by an implementation, then that leads to impact, which is great. So now we have science and excellence in science that leads to impact in society. But what about the blue sky sciences? What about fundamental research? What about the sciences that are not related to development topics? For example, astronomy or say quantum computing, or mathematics, theoretical mathematics and philosophy, etc. How are those related to the development of our societies? Well, first, the most direct impact, of course, is we think of skills development. Education leads to the development in principle, but we need to ask, is that process passive or active? Are we sitting doing our astronomy research and having our students and thinking, oh, eventually it will trickle down? Or are we actively developing the country through this development of skills? And I think astronomy as a science has an advantage compared to maybe some other sciences, that it is inspirational. I think all of us, when we were children, look up at the sky and wonder, you know, what's out there? What's up there? What is this? What are these pricks of light that are so far away? And we dream big. And in South Africa, very early on, the perspective was taken after the transition to democracy is that dreaming big should not be something that one can only do once one has everything else sorted, you know, enough infrastructure, enough development in society. Dreaming big should not be a privilege. Dreaming big should be allowed by everyone. And I think this is very, very important, because we see in communities that don't have everything, that they dream just as much as communities that have everything. And it's dreaming big that leads to acting and changing and developing and creating businesses and dreaming big is an essence, essential to development. And astronomy is inspirational. So let's look a little bit at South Africa. So astronomy in South Africa has colonial origins. The Royal Observatory in Cape Town was established exactly 200 years ago with the goal of mapping the southern skies for navigational trade routes between Europe and the East. And so it was important for the navigators to be able to map their location. And for that, having accurate time is critical. So when the observatory was set up, it was set up as a time measurement. And to this day, there is a cannon that is fired at noon from the observatory every day for the ships in the harbor to be able to set their clocks accurately. So it's really a sort of a colonial trade history that established astronomy in South Africa. There was the Johannesburg Observatory that was set up as well, and they were merged in 1972. And now, obviously, there are South African research institutions with a long history. In radio astronomy, the Hartbeespoort Radio Astronomy Observatory, HARTRAO, was set up as a NASA satellite monitoring dish in 1960, and then 1975 was handed over to South Africa. So that dish is where we come from in terms of radio astronomy, and it's still working, and it's part of the very large baseline interferometry network globally. So it's modest start in astronomy, but astronomy as a science has a fairly long history in South Africa. Now, in 2005, the Southern African Large Telescope was inaugurated, also known as SALT. Now, SALT was one of those projects of dreaming big. This was South Africa thinking, no, we're going to build a world-class facility in South Africa for Southern Africa. It is 100% South African built. It's a 10-meter class optical telescope with a segmented mirror. And it's the biggest single dish optical telescope in the Southern Hemisphere. It was also, and this is a tribute to the ingenious engineers and astronomers that built this telescope, it's about 5 times cheaper than a similarly powerful telescope elsewhere in the world. And the reason for that is that the mirror is spherical and not parabolic, which means that each piece of the mirror is identical. And the aberration that the spherical mirror causes is then compensated for in the receivers of the telescope. So instead of having to have unique mirror segments, all the mirror segments are identical, which obviously drove the cost down. So this telescope has been part of world-changing discoveries. For example, it's been part of the follow-up of the first detection of the gravitational waves, where it helped find the optical, the origin, the optical counterpart to the gravitational wave. So it's really a fantastic instrument that is regularly part of world-changing discoveries. But what also came with the Southern African Large Telescope was a program called the Collateral Benefits Program. It started when the telescope was built and aimed at creating employment in the local community. As you can imagine, it's in a place that is a semi-arid desert with very little development. And the towns, they are very rural. There's a very high unemployment. The biggest industry is sheep farming. So there's a lot of lot of unemployment, a lot of problems of alcoholism also in the communities. And so this collateral benefits program created jobs to local skilled people and skilled people up to build roads and build the telescope. But then when the telescope was built, the program continued to have community engagements and make sure that the community benefits from the existence of a world-class scientific facility in its neighborhood. And that led to the development of astrotourism in the community. It went from a couple of guest houses to over 50 guest houses. It has a community development center where you have computers that share the high bandwidth internet, academic internet of the telescope for the community, which is a place for then children and young and the youth to come and say study for school and learn skills and be connected to the internet for free for the community. And programs like that have a big impact on the local community. Then we come to South Africa's participation in the Square Kilometre Array. This is a picture of the Meerkat telescope, the 64 dishes out also in the Karoo Desert that form the precursor telescope to the SKA phase 1 that South Africa has built. This telescope was inaugurated in July 2018 and is performing beautifully. It was delivered on spec, well, above spec, on time and on budget, which is, you know, in astronomy not always the case. So it's a really beautiful success story of science and technology in South Africa. But there's a long story to this. So how did we get there? So first in the 90s, SKA was being dreamt up by astronomers. And by then, the technology needed to have a radio telescope of the scale of the SKA didn't exist. The data challenges, even the communication, the transport of data challenges, the energy, all of those technologies that are required to make the SKA work didn't exist. So it was really, again, we come back to dreaming big. In 2000, the original Memorandum of Understanding was signed to start a bidding process to host where in the world would the SKA be hosted. And in 2003, 2 years before inaugurating SALT, South Africa decided to enter the race to host the SKA. In 2006, there was a site shortlist that included Chile, South Africa, China, Australia, and New Zealand. And very quickly, that race was just between South Africa and Australia and New Zealand. And in 2012, the site selection was done based on a bidding process that included obviously the quality of the environment, the radio quietness, the capacity in country to be able to host such a facility in terms of power, in terms of infrastructure, in terms of skills, etc. And South Africa and Australia were both awarded this hosting of the Square Kilometre Array. So immediately, the Meerkat telescope was built. It was originally the KAT, the CAT, which stood for Karoo Array Telescope, which was 7 dishes that were just a sort of a demonstrator that the dishes could be built. And then the meerkat was designed and built. Meerkat means in Afrikaans more of cat, more of the Karoo Array telescope, but it's also a very cute animal that is found in the desert where the meerkat is built. So it's a bit of a pun. I think in astronomy we love those puns. So the meerkat telescope was inaugurated in 2018, and well, the timeline says that SKA phase 1 construction should be complete in 2021. I don't know if that is going to be the case because, of course, the coronavirus pandemic has disrupted a lot of things. But it is in construction, and the first dish and the first few dishes are definitely up. But there's also a plan to increase the meerkat to 20 additional dishes. So we keep building, and the telescope keeps delivering. So that's how South Africa, that was a very modest radio astronomy country with very little capacity, and was pretty much unknown in terms of global research in radio astronomy. Sorry. That's how South Africa managed to come to the world stage with one of the best telescopes in the world, radio telescopes in the world, operating now in 2018. So this is really an active effort here. But there's another story behind it. And this other story is that the country would not have invested in something like big astronomy if it didn't have the potential to benefit in terms of development. So in 2007, the Astronomy Geographic Advantage Act was passed. And this creates an astronomy reserve in the Northern Cape, which is a province where both salt and the meerkat are located. In this picture, you see the original Karoo Array telescope, some of the 7 dishes. You'll see they're slightly different from the meerkat dishes that we've seen before. And this act of parliament was very important to preserve this area for astronomy, promising that the developments that come that can interfere with astronomy, whether it's light pollution or radio frequency interference, didn't happen. But that in itself triggered creativity and engineering in the country. So the quote that you can see on this slide is about one of the major telecommunications companies in South Africa providing cell phone signal, developed an antenna technology that is directional, so that they could create cell phone coverage as close up as possible to this astronomy reserve without interfering, without creating radio frequency interference. So they provided omnidirectional coverage, but also blocking the radio frequency transmission along a single direction, which was in the direction of the telescope. So they managed to create these, and this is something that was created domestically. So already we see here domestic technology creation that happens, and that happens thanks to this investment in astronomy. So protecting this area didn't result in less development, but more clever development in that sense. In this slide, I'm quoting Cisco. Cisco is well known, is a big IT company globally, and they came and invested over 66 million South African rand, so our currency, including equipment and engineering support for PhD students at one of our universities, Nelson Mandela Metropolitan University, which is now known as Nelson Mandela University, to work on broadband technology. And they claim themselves that the supplied research lab is directly linked to the SKA, right? So they saw the SKA as an opportunity that, you know, if the SKA is coming to South Africa, it means there's excellence in engineering and in science and technology, and they will need more. So we see this as a company an opportunity, and they set up this research lab at one of the universities. I think what's interesting here is that they didn't go to one of the more famous universities. They didn't go to the University of Cape Town or Stellenbosch University or Wits in Johannesburg. They went to Nelson Mandela University, which is not one of the most famous universities. So really shows that it doesn't necessarily centralize the benefits in the bigger metropolitans, which is interesting. So we've seen there's quite a lot of technology development that has happened, telescope building, so engineering, challenges, cooling, computer infrastructure that cannot create radio interference. So radio interference insulation is also part of it. In fact, next to the SKA, there's a massive, if you will, a supercomputer underground with a huge cooling infrastructure just to get the signals from the telescope. But then once we have data from the telescope, how do we empower our researchers across the country to be part of the adventure and to be able to use the data? Because the SKA itself has been sometimes called an IT project or a big data project because of the size of the data sets that come from the telescopes that are impossible to handle the old way. You know, you can't download it to a computer and process it. It is massive. We're talking, you know, we're really talking about a new generation of data sets here. And so to be able to do that, the one technology that we've developed specifically at IDEA, the Inter-University Institute for Data Intensive Astronomy, is cloud computing. Because so IDEA was set up in 2015. And the goal of IDEA is to build within the South African university research community the capacity and expertise in data-intensive research to enable global leadership on MeerKAT large survey science projects and on other SK Pathfinder telescopes. So really here the idea is to have a cloud computing facility with web interfaces so that people, researchers at universities, but also students, and especially people at universities that don't necessarily have the ability to make a capital investment to build big clusters, to be able to access the large data sets that come from the MeerKAT telescope. And so we have students, we have postdocs, we have young researchers and more senior researchers who are able to work on MeerKAT data in South Africa. And it's very important for the country that has invested in this telescope that South Africans are able to use the telescope and the data isn't just shipped, say to, I don't know, to Europe or to North America or whatever. So it's very important to be able to do that. So cloud computing is one of the technologies that enable that. But let me come to maybe the even more important thing here is people. So the SKA program, SKA South Africa, that bid to host the telescope, from the beginning decided to have a human capital development program, a very, very big program. So as of 2019, they had over 1,000 bursaries that were distributed. The 2020 ones have just come out, so I need to update my slide. But these are bursaries to study astronomy at undergraduate, at postgraduate level to do research. There's postdoc fellowships, but there's also bursaries to study the engineering that is needed to build the telescope, and even all the vocational technical training that is needed, say, to maintain the telescopes, you know, such as electricians and all of that. So all of this massive human capacity development program really was from the beginning on the agenda of the South African bid to host the SKA, because it was much more about than just building a telescope. It has to uplift the whole country. And so there's an annual postgraduate bursary holder conference that is coming up just in the first week of December. And every year, the holders of these bursaries are able to present their work. And it's, I don't know if any of you have been able to attend one of these conferences, but they are fantastic. We have radio astronomers who are at the top of the field, directors of big institutes from around the globe who usually come. This year it's virtual, and meet all the students. So you can imagine the networking possibilities, the possibility to showcase the students' work, the research, and really embeds them in the global radio astronomy community. And also there's the program of SK research chairs that the government has set up to make sure that while we build capacity in the country, that we have these research chairs, a lot of them are international, come and build that capacity in this country. And that program has also had a lot of impact. Now, I want to mention the impact on what we called historically disadvantaged institutions, HDIs. So those are universities that before the end of apartheid in South Africa were say for Black students. So there were, you know, before the end of apartheid, people were separated by race, and there were universities that that were only for Black students. And those universities, you can imagine, were quite under-resourced. And so recently, the historically disadvantaged institutions have been a focus of the South African government in science and technology development, but also higher education. And so we have worked, and this program has worked to uplift these universities. The university that I come from, the University of the Western Cape, is one of those. And it turns out that it started an astronomy group just about 10 years ago. Now, in the 2016 Nature Index, UWC was ranked #1 in physical science, not just in South Africa, but in Africa as a whole. So it really has had a massive impact on this university. And I'm mentioning here also Solplaki University, which is a university that was started in 2014 that was based around data science. And Solplaki University is in Kimberley. Kimberley is the capital of the Northern Cape province, where the SKA and SALT are. And it's a very, very isolated place. Kimberley is actually known for its diamond mines. Kimberlite, the rock where diamonds are found, that is named after the town of Kimberley. So Kimberley is a desert town in the biggest and least populous province of South Africa that did not have a university. They opened Solplaki University with a focus on data sciences. So really, the human capital development that comes along with investing in a project like the SKA has been very impactful. So we also, on top of, say, formal programs like university programs and things, we also run a number of informal programs and additional things like hackathons, and I just want to mention them here. So at IDEA, we support these. We use the cloud computing, and we enable these groups of anywhere between 25 to 50 students to come and take part in big data research schools and in 2 to 3 day hackathons where they develop big data skills. So they learn Python, they learn to use Jupyter notebooks, they have big data challenges from satellite imaging analysis to the sentiment analysis of Twitter feeds, to, you know, all of these big data skills that we develop in astronomy, but can be applied to other domains. And with it, we also try to develop entrepreneurship skills where, say, a research project is thought of as a startup, and we have simulation and role play, and they try to fundraise for a startup, and we have CV labs and things. So all of those things highlight that these big data skills development are not limited just to astronomy, but we really try to help young people become apt in big data skills beyond just astronomy, which is, again, where we try to make the circle bigger of the impact of having excellent astronomy in the country. So I had a couple of slides where I show you some of our astronomers, but I don't think, I can't just, you know, show faces like that, but I'm going to show you this. This is a screen capture from a website called Astronomy in Color that was just launched. It's an initiative that has been launched by 2 master's students, so Tiamiso and Kilebogile, who are 2 master's students at the University of Cape Town. And this really shows how young scientists are taking the lead. They're owning their space, you know. So science and astronomy in South Africa is really changing. The face is changing from a sort of a very limited, very white leadership and community to a much bigger community, much more diverse, much more representative of the South African population. And these are not just students, you know, they come through, they do their PhDs, we have lecturers, senior lecturers, professors. So it really is now changing. And this is a very significant for South Africa, especially because of its history of racial segregation. And so when you think astronomy in South Africa, you now think of these young people. They're all very keen to do outreach. They all have a presence on social media. They're all very active, and they are a source of inspiration, because the children in South Africa who see these astronomers and these scientists, they identify with them. Whereas, 15 years ago, they wouldn't necessarily identify with who were, say, the leaders in astronomy in the country. And so they now have role models that they didn't have before. And the reason I'm saying this is because what you create when you create a generation of people like that is not just, individuals. You create something that you don't have control over. You create great people, and then they go and build. And so I think what is beautiful that we're seeing right now in South Africa is that all these young people owning their space they own the momentum. The program is not about, okay, now we have so many bursaries and things. No, this is now, these people are having an impact on lots of things, and it's out of our control. We've sowed the seeds, and now we see the forest grow, and it's really, really quite inspiring to see. And so I just want to borrow a couple of slides from another presentation I've given, saying that these efforts that we have to stimulate development using astronomy is something that we try to bring also in our international collaborations, and in particular across the BRICS nations. I mean, the reason I'm here today is because we've had a meeting about a BRICS collaboration, which is fantastic. And so with big data and big compute, we are able to build bridges with industry. I mentioned earlier the hackathons and the industry simulations, but also through triggering internships, cross-disciplinary interventions, tools and skills, and the ability, to have real-time big data streaming and to analyze that is something that is highly in demand in industry. And so the connections are definitely growing with industry. And I mentioned here a few of the sustainable development goals that this impacts. And then secondly, also that I just want to mention that dreaming big about astronomy also has an impact for life on Earth and how we live. With these technologies, we can develop early warning systems. When we say we had a optical follow-up to gravitational waves, this is a quick reaction system where we are able to mobilize scientific facilities very quickly. Data analytics skills are very important in all sorts of fields, in particular, say, for example, health. And we've seen that this year. I think 2020 is really the year of a quick response to a global health emergency. So the data processing capacity, the interdisciplinarity, and all of those things, when we think of astronomy, we can think of near Earth objects, but a lot of astronomers have applied their skills to assist with the COVID-19 pandemic this year. And so we develop skills that are also useful for disaster management and public health emergencies. And so life on Earth is also part of what drives us. And when we develop astronomy, we don't know where all these young people will do. Some will find their calling in astronomy, some will find their calling elsewhere, but the skills are there. And astronomy and a project as ambitious as the SKA has really driven the technology development and therefore the development of skills. And I would like to finish on this image, which was the launch image when the Meerkat telescope was inaugurated. So this is the clearest radio image of the center of the galaxy. It was taken by the Meerkat telescope. And the science that comes out of this is just the beginning. And we have young people, we have PhD students who are PIs on projects on the Meerkat telescope, and just, this is just the beginning of a completely new perspective that we have on the galaxy, but also that we have on our own country, and where we're going with this big dream of astronomy. And so, just to conclude, I think scientific excellence really does stimulate development, but if it's an active process, it's fundamentally multidisciplinary and interdisciplinary. Transformation, the development of people is key, and it really needs real efforts. But a concerted investment in scientific excellence has placed South Africa anyway firmly on the world map of science. And I'm just going to go back to this image, and thank you very much for your attention.
Thank you, Carolina, for the very interesting talk. We have now time for questions from the audience.
Well, I would like to, first of all, thank you very much, Carolina, for coming. And I wish I were, 30 years old today rather than 70. So I got very inspired. I wish I had another lifetime to start all over again. And I wanted to invite you to come to Brazil. I mean, you got to be our representative.
I would love to.
You have to take this
presentation
presentation to the ministry, our ministry. Fantastic. Thank you very much. Very inspiring. I hope that all the younger people here enjoy the presentation. I think it's marvelous to see how a science that doesn't look like strategic can actually impact the whole thing. I actually was in South Africa a couple of times in the Kalahari Desert. I observed there, and I see the evolution of South Africa is just unbelievable. And I'm a little bit jealous, okay? Just a little bit. Thank you.
Thank you for your kind words.
More questions? Okay. Carolina, I'd like to ask you a question. It's, in my group, we are actually trying to develop some kind of network to assist us on stellar occultations. And in your experience of actually bringing something, some investment, some economic development, what are, in your opinion, the biggest challenges in this kind of projects like Meerkat and the Salt?
I think one of the big challenges is the ability to maintain the commitment in the long term from government and from funding agencies and things. In South Africa, we've really seen that it's been a very long-term investment and strategic investment, right from 2000, well, even before 2000 with the SALT, and then with the SKA, and it's been consistently on the agenda across. The ministers have come and gone, the presidents have come and gone, but consistently astronomy was high up on the agenda. And I think that in itself is really quite an achievement, because we see a lot of changes in priorities as cabinets change and policy priorities change. And I think the fact that it's been so consistent over the long term is really yielding benefits today. But it's a very challenging thing. And I think we've had very good champions, people like Bernie Fanneroff, who have been able to have the ear of government and make sure that this stays on top of the agenda over such a long time.
Okay, thanks.
I presume that being an international collaboration has also helped a lot, right?
Yes.
To give this.
Exactly.
I have a question also, a more technical question. How is the coordination between the Australian site and the South African site? Are data being transferred between them? How does it work, or they work independently?
Okay, this is a very good question. So the whole data management of the SKA as a whole is still work in progress. So there's a big working group, international working group as part of the SKA organization. So now the overarching, the IGO, intergovernment organization that is managing the SKA, that's based in headquarters are in Manchester in the UK. They are developing regional science data science centers. So these are centers where the data will be stored and archived and be made available, because it's not viable to transfer terabytes of data across oceans as soon as there's a research project. So there will be a network of regional data science centers across the world. And of course, Australia, there will be in Australia, there will be in South Africa, there'll be in Europe, there'll be in all the partner countries. And the technology for that in itself is also currently being developed. So we're working very much on the cloud computing side of things using OpenStack. And we have a lot of international collaborations in computer science for that. So that's also work in progress. So I think we in Australia, they also have cloud computing. There's a research cloud based at ICRAR in Australia. And I think everybody's building a telescope. Everybody's also building, the back end of the telescope as well. And so it's all very much work in progress, but very much collaborative across the SK organization and partner countries. Yeah.
Fantastic.
Okay, well, we have a question here from Tamiris on the chat. She says, I wonder if there is any focus program for girls?
That's an excellent question. I don't think within the SK itself there is, but there are a lot of programs for visibility of women in STEM in South Africa. And if I can go back to the slide where we had the astronomy in color, you can see this is just a screen grab of the members page. And you can see the majority here are women. And in fact, there's not a single man on this. Oh no, there's one guy. So no, hang on. Well, if you go astronomy in color, the URL is aic.sao.ac.za. I can put it in the chat. It's a very interesting initiative. And you'll see there's a lot of girls and a lot of women, young female astronomers and scientists in this country. So there are a lot of programs, and more women in science are visible indeed.
Okay, thank you. More questions?
Let me see if I can find the chat so I can put the URL in there.
Okay.
I was very impressed also with the bursaries. I mean, those grants are for how long? 1 year, 2 years, 1,200 of them. It's a large number. I mean, I was very impressed with that. Is it for how long? Is 1 year grants or? So
it's for the studies. So, for example, an undergraduate bursary will cover 3 years of undergraduate studies, sometimes 4. Honors, so the way it's structured in South Africa is 3 years until bachelor, then 1 year honors, and then 2 years masters, and then 3 years PhD or longer. But that's what it's planned. And the bursaries, the normal government bursaries, if you will, are not very. They're not. It's not a lot of money at all for the students. But the SKA bursaries are a little bit higher, and they've really ensured that the recipients of those bursaries are able to focus on their studies and don't go hungry and don't struggle to pay rent and so on. So the SKA bursaries has been a really, really impactful program in that sense, and has really enabled students who come from very humble backgrounds to become,
to actually participate. I also have another question about the hackathons. I mean, are they open for anybody, or because that would be very interesting to participate, some of our people to participate? Can we register, or just for local people?
So until now, until 2020, say before pandemic, they were all physical. So we had in a location, but they were using the cloud. So the key requirement was for that location to have good connectivity so that they could use the cloud. Now, this year...
Now it's a different reality.
Yes, this year is different. We had last physical one in February, well, early March, actually. And now it's all gone virtual. So we had one that was based in Zambia just a couple of months ago. And that one was, it was half in person, half virtual. So the tutoring and the talks were virtual, but the participants were from the University of Zambia, and they actually came into their computer science department, and there was, you know, masks and social distancing and all of those things were applied, but there was sort of, it was sort of an in-between one. Now in the one in December, we're doing in partnership with the Space Generation Advisory Council, which is a youth organization affiliated with the International Astronautical Federation. And this is a Pan-African one. So it's open to people all over Africa to register. In fact, the deadline is today to register for it. But also because we offer the cloud computing for this, and the cloud is also the one we use for Meerkat data. We can't open 200 to open it to 200 teams, because it's also a research facility that so we focus on the development of skills, especially in places that are strategic for us. So this one that is coming up, one of the focus is on the Africa AVN countries, so the Africa partner countries, so the SK, because the SK will be not just in South Africa, the actual facilities will be built in other countries all the way up to Ghana. And so we focus on these 9 partner countries to develop, you know, the skills and the big data skills in those. But this one is Pan-African, so it's open to the whole continent. But I mean, the model is open, you know, the model to run a hackathon.
Can be expanded, of course.
Yeah.
Now, I was thinking about in the context of the BRICS.
Right.
That would be something concrete that could be done without having the blasting from all the ministries involved. I mean, something that could be done at our level, not necessarily at a higher level.
Yes, exactly. No, that's a really good idea, and we're very happy to be part of that and share our experience.
Okay, I think that's it. This presentation will be available on our website and on LIneA's YouTube channel. So for the next week's webinar, we will have Santiago Ismael Ferreira from the University of Oslo talking about a unified scenario for the origin of spiral and elliptic galaxy structural scaling laws. Thank you everyone for attending, and a special thanks to Carolina. And also, Carolina, if you could stay with us a little longer.
Yes, of course.
Okay. And everyone, have a great day and see you next week. Bye-bye.